moins 1 minute.
1 minute to launch. We are live at the Guiana Space Center. And we're launching Hispasat 36W-1 for the Spanish operator Hispasat, and the first of the European Space Agency's small GEO family of platforms, built by the German contractor OHB. Our very best wishes to all the teams.
Largage du Macazedem. À tous de DDO. Attention pour le début de la séquence d'allumage lanceur. Top, à 0-20 secondes. Largage du VKM, allumage triétage. À 12 de DDO. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Et décollage VSS. Les paramètres à bord sont normaux.
And they are off! Hispasat
Stabilisation correcte
36W-1.
du lanceur.
The European Space Agency's first ever small GEO platform has begun its journey. Soyuz is hauling itself against the pull of our planet. The boosters are doing all the work at the moment. They're delivering 80% of the thrust right now.
Les paramètres propulsifs sont conformes à l'attendu.
He's telling us that the propulsion is as expected. So the booster's job is to get us away from Earth. We need a lot of firepower to do that. Soyuz is heading out east over the Atlantic, and that's a first for the Soyuz vehicle here at the Guiana Space Center. It's the first time it's headed east. Usually it goes west
Tous les
or
paramètres à bord
north.
sont normaux.
He's telling us everything's normal, everything's going according to plan. You can see our altitude there, 43 kilometers above the Earth, down at the bottom left, and this is the scheduled moment for separation of the boosters. This is an image from a previous launch. Look at that.
Séparation des blocs BVGD.
They twist and turn as they fall of the way. It's all part of the plan. So we're now burning the main core stage, which is now called the second stage, or Block A.
Stabilisation correcte du lanceur après séparation.
Everything's going well. A word about the confirmations of major events in the flight. We're seeing the key moments happening at the right time, but we get the actual confirmations of those milestones slightly later. That's perfectly normal. That's because it takes a little time for the information to get from the launcher to the range operations manager here at the Guiana Space Center. And that's because it goes via Moscow, where it's validated before coming to the Launch Control Center here at the CSG.
Le déroulement du vol est conforme à l'attendu.
Top right-hand side of the screen is the trajectory, the planned trajectory. The white dot is the actual position of the launcher. Distance in the bottom middle there is the distance from the pad if you were to draw a line along the Earth. So we are now jettisoning the fairing that was protecting the satellite during the launch. But we don't need it anymore, because if you look at our altitude on the bottom left, You can see that we're 120 kilometers high, and we have crossed the border, the Kármán line as it's known, effectively the border with space. So there's not enough friction to cause us any problems, and we can see our satellite for the first time.
Les paramètres bord sont normaux.
Our speed there on the right-hand side, 3 kilometers per second at the moment. We'll be getting faster later. Let's just remind everybody that's kilometers per second. So we can see our satellite, there it is, on the right. The rectangular or square-looking sections, the blue sections are the solar panels, and the gold structure is the frigate upper stage. And now we have the scheduled separation of the second stage and ignition of the third stage. Actually, it's the other way around. Ignition of the third stage first and separation of the second stage later. That's because Soyuz...
Séparation, bloc A et extinction.
There we go, have the confirmation there. Soyuz uses what's called a hot stage technique. That means that the third stage switches its engine on while the second stage is still burning. That's why the Soyuz has an open area in between the second and third stages, a kind of lattice work area. The launch campaign manager for OHB. Everybody focusing hard here. The computer-generated images that we are looking at, there they are, that's showing us what the experts have calculated is happening.
Le vol se déroule comme attendu.
This was 6 minutes and 7 seconds ago. The 16th Soyuz to lift off from the Guyana Space Center. It's the first time it's flown east, but it's also the first time that it's carried a satellite or carrying a satellite to geostationary orbit from the Guyana Space Center. Not the first time that Soyuz has taken a satellite to geotransfer orbit, but the first time from here. Galileo on the top left of these are the tracking stations you can see here. Galileo is the one at the Guyana Space Center. And Natal is the next one to pick up the signal. That's in northeastern Brazil.
Acquisition de la télémesure par la station de Natal au Brésil.
He's just confirmed that we've picked up the signal there in the Natal tracking station. That was a superb launch, wasn't it? Really beautiful. What a sight. So that was 7.5 minutes ago. We are heading off.
Suivant les trois axes sont conformes à l'attendu.
He's telling us that all 3 axes are going according to plan. They're as planned. Heading off on our 32-minute journey. Here's more about the satellite.
Hispasat 36W-1, previously called Hispasat AG1, has been built by OHB System AG in Germany, which has been developed under ESA's Artist for Advanced Research in Telecommunication Systems program.
Hispasat 36W-1 is a very innovative satellite mission that we have been working on with the European Space Agency and different European companies led by OHB, and with an advanced payload developed by the Spanish industry, led by Thales Alenia Space España and Airbus Defence and Space España. It is an excellent example of what public and private collaboration in the space sector should look like. We are sure that it will become a reference for the future PPPs in space in Europe.
We would like to thank Hispasat and ESA for the confidence put in Arianespace and its fleets of launch vehicles. And I look forward to seeing you soon for a future launch campaign.
Absolutely, and there's Beatriz there, who is indeed Spanish. And a big welcome to all the Spanish delegation and also to the German delegation here today at the Guyana Space Center. Coming up on separation of the third stage, which is our next event that is scheduled now. Superb images, you can see the curvature of our planet there. Look at our speed on the bottom right, where it's confirmed the separation there. Speed 6.85. And we picked up, or lost the signal rather, in Gallo. So frigate's getting ready to switch its engine on, frigate being the upper stage, the gold structure there. It's giving a quick burst of acceleration using small thrusters. And the idea of this is to push the fluids back into the tanks to make sure that the feed lines and propellant is going to ignite properly. It's a little bit like when you're driving in the car and you put your foot down on the accelerator and you get pushed back against the seat. So this is the scheduled moment that the frigate upper stage switches its engine on, and we're really starting the next phase now of the journey as frigate takes the wheel. So it's that gold structure, as I said. On the left you can see the satellite telling us everything's normal. And frigate actually has 6 spherical tanks, and they're organised in a circle. 4 of those contain propellant, and then 2 of them are for avionics. That's what you normally find in the cockpit of a plane. The flight control systems, navigation, communications, that sort of thing.
Confirmation du premier allumage du moteur frégate.
Yep, we've had confirmation there. The frigate upper stage has indeed turned its engine on. And the satellite is attached using a very special dispenser. Hispasat is a leading Spanish communications satellite operator, and they have 25 years of experience on the Iberian Peninsula and also in Latin America, where the group is now the 4th satellite operator. Hispasat 36W-1 is the 7th spacecraft that Arianespace has launched for their friends at Hispasat. The first ones were Hispasat 1A and 1B. Some of you may remember those. That was back in 1992 and 1993. And since then, Arianespace has launched Amazonas 2, 3 and 4A. And 36W-1 is number 7. It's a cutting-edge satellite full of innovative technologies.
Hispasat continues to grow with the launch of a new satellite, Hispasat 36W-1, which will be located at the 36° west orbital position above the Atlantic Ocean. Hispasat 36W-1 provides the operator with additional space capacity in Ku band for Latin America and Europe, as well as capacity on the Ka band for the Iberian Peninsula and the Canary Islands. This satellite is involved in the Small Geo Platform's first mission, developed by the manufacturer OHB Systems AG, together with the European Space Agency and Hispasat, and it has a launch mass of 3,200 kilos and dimensions of nearly 5 meters long by 2 meters wide. This platform will increase the capacity of the European industry to play a key role in the field of medium-sized commercial satellites. The new satellite is the first to be manufactured by OHB Systems AG and is included in the range of small geostationary satellites. It has 20 transponders in Ku band and capacity in Ka band, as well as a regenerative digital processor, an innovative antenna that actively receives the Ku band in reconfigurable beams, 2 deployable antennas, and altitude control on the 3 axes which ensure better orientation precision. The company, OHB Systems AG, is responsible for its integration, the completion of all technical tests, and putting it into orbit.
Esta novedosa plataforma aportará nuevas oportunidades a nuestros clientes en América y Europa en banda KU y Ka. El satélite Hispasat 36W-1 está diseñado para soportar tanto redes de datos como aplicaciones audiovisuales con la máxima calidad y flexibilidad. Su mayor potencia permitirá comunicaciones a mayor velocidad que los satélites de generaciones anteriores.
The Spanish industry has made an important contribution to the construction of the Hispasat 36W-1, as well as to its ground segment. One of the main additions is the regenerative payload of the latest RedSat generation, which has an innovative design that will allow Hispasat to use satellite power in Ku band more easily and efficiently, and to optimize its service at all times. It is made up of a powerful receiving antenna that is active with configurable beams, RedSat DRA, manufactured by Airbus Defence and Space España, and a processor, RedSat OBP, manufactured by Thales Alenia Space España, which reconfigures and rebroadcasts the signal received and is compatible with the standard DVB-S2. Thanks to RedSat, Hispasat will be able to adapt this satellite to the changes that may occur in the mission following its launch, such as the incorporation of new clients in different areas or a change in the orbital position.
Estamos muy orgullosos de la misión Smart Geo. Es destacable en esa misión el papel jugado por Hispasat como líder de la misma, que ha servido como apoyo para que la industria española pueda participar activamente en ella. Fruto de esa participación, queremos destacar el éxito alcanzado con los 2 elementos innovadores tecnológicamente incluidos en ellos, la antena activa ELSA y el procesador RedSat.
Hispasat 36W-1 satellite represents an important milestone with the inauguration of a new orbital position at 36° west, and it significantly increases the capacities of the operator, which, following its launch, will be able to respond to the needs of its clients on both sides of the Atlantic more easily and efficiently. This satellite paves the way for a new generation of more flexible and adaptable satellites that are intended to improve communications.
Well, packed full of advanced technologies, a very exciting satellite. Right now, it's in the visibility of the Ascension tracking station, hurtling across the Atlantic Ocean. Ascension's an island in the middle of the Atlantic. It's quite small, actually. It's about 88 kilometres squared, and apparently it has roughly about 1,000 people on the island. And according to Wikipedia, it's the remotest populated archipelago on Earth. The island is part of that archipelago, the Tristan da Cunha archipelago. It was a stopping point for airliners during the early days of international space travel, and I believe that NASA had a communications dish there during the space race in the 1990s. I think it might have been used to track the Apollos. So here we are, 18 minutes now into our flight. And gosh, technology is racing ahead here on Earth, isn't it? Everybody wants new devices, everyone wants faster internet, more bandwidth, and the demand for communications from space seems to be growing. One thing's for sure. There we go, he's announced the Ascension tracking station. The markets are constantly evolving, and right now we're seeing increasing preference for smaller telecommunications satellites on geostationary orbit, satellites that are flexible and modular. And that's why the European Space Agency... Okay, we picked up the signal there at the Libreville station, that's on the west coast of Africa. So these changing markets, ESA wanted to help European industries to compete on the world stage and to have a solution to offer, which is why they decided to develop the platform under the ARTIS program, ESA's program for advanced research in telecommunications systems. Let's take a closer look at Small Geo, Europe's new platform. Meet Small Geo, the first of Europe's new family of satellite platforms launched into geostationary orbit. The European Space Agency developed Small Geo to help Europe's industries compete on the world stage and get a foothold in the fast-growing market of small commercial satellites. For this first in the series, ESA partnered with the Spanish telecommunications operator Hispasat, a new approach for speeding up access to space for advanced technologies.
It indeed, because Hispasat and ESA were able to join forces, that we were able to develop a satellite with such a level of innovation. On the one hand, a new platform with a new satellite prime contractor. On the other hand, a payload embarking also a high level of innovation. And indeed, separately, neither Hispasat nor ESA would have been able to undertake such a complex development.
This partnership allows the German prime contractor for the spacecraft, newcomer OHB, to test the platform in space and position itself in the small group of European industries who make telecommunications satellites. In space, size counts. Small Geo is designed to carry payloads of around 300 kilograms, in this case Hispasat 36W-1, with its innovative RedSat payload offering better signal quality and connectivity. It'll provide faster multimedia services for Europe, the Canary Islands and South America. Small Geo is modular, so it can be fitted out according to each customer's needs, helping them to keep up with continually changing TV, mobile and internet markets. The spacecraft is state-of-the-art and carries the very latest technologies on board.
Very much today a trend is to go towards full electric propulsion satellites. This is a class of satellites that only have electric propulsion on board, which is a high-efficient system that allows achieving important mass savings. So we are able to put in space a satellite with a similar capacity of a full chemical one, but with much lower mass, which means less launcher cost and compatibility with more launch vehicles.
With Small Geo, European industries have a better chance of competing with manufacturers worldwide, whilst developing services that benefit everyone in Europe. So yes, a new way of working, although it's not actually the first time that the European Space Agency has done a public-private partnership. You may remember HILAS, I believe that was the first one. ESA has been very positive about the collaboration with Hispasat, and I'm sure that they'll all be doing it again. He's telling us we've got 5 minutes left of propulsion on the frigate upper stage. So Europe has a new prime contractor for geostationary satellites, OHB. Already 2 primes in Europe, Thales Arianespace and Airbus, and now there's a third one, the Gang of 3. This is an important flight for OHB, the German company, because it allows them to test their craft in space and certify it. Germany is an important European space power. It has a growing influence in space activities, plays a very important role in the decision-making bodies of the European Space Agency and, of course, within the European space industry generally. And it's also a key partner for Arianespace. In terms of OHB, Arianespace has 11 more satellites planned of theirs to launch, and 3 of those using the new small GEO platform. If you look on the right-hand side of the trajectory, you can see that whereas before we were using all our power to get away from the Earth, you can see we were travelling vertically up into space. Now we're using our power to go faster and faster and climb higher and higher. You can see in the curve that we had a bit of a dip in the altitude, sort of a roller coaster shape. Well, now we're climbing up into space to get to the point where we can release our satellite. It's been a great relationship between Arianespace and its partners.
We have a very long-standing relationship with a strong sense of cooperation and partnership with Arianespace. This special relationship has allowed changing the launcher from Ariane 5 to Soyuz at a late stage of the program to ensure an early launch date in a very smooth process. For the launch, it is always with great pleasure that we come to work in Kourou with our colleagues from Arianespace. We have a very good friends here, and it is always great to work in such a friendly environment. The campaign has been really smooth, and we hope that the launch, LEO and IoT will keep in the same way.
And we are using the frigate upper stage to deliver our satellite. A frigate was, interestingly, originally designed by the Russians as an interplanetary probe. You can see it there, the gold structure, the round gold structure with the spherical tanks. It was then adapted to fly on Soyuz, and I believe that the first time it was used on Soyuz was to release the cluster satellites into space. There are 4 satellites bouncing around our magnetosphere and checking it out. It can switch its engine on up to 20 times, and it can take its passengers virtually anywhere they need to go, so any kind of orbit. So that makes Soyuz ideal for launching all kinds of things, including constellations. Hispasat 36W-1's transfer orbit is 1,300 kilometers above the Earth, and it will need to be travelling at a speed of 8.83 kilometers. Our next tracking station to pick up the signal is Malindi. Right now we are flying out across Africa. And Malindi is in Kenya, which is the east coast of Africa. Malindi will be tracking the launcher during the separation. And we're getting ready to switch off the engine shortly. Frigate reduces its thrust slowly. That's because engines prefer to run down remaining fuel at a reduced power. It's steadier. Travelling at 9.3 kilometers per second. This is the scheduled moment that the frigate upper stage switches its engine off. And we're now entering what we call the ballistic phase. This means the Computer has sent the command to switch the engine off, and we are travelling without propulsion. It means that we're on orbit. We are travelling high enough and fast enough to cruise without the engine. Our altitude 718 kilometres above Earth and climbing. Our distance from the pad, we've travelled nearly 11,000 kilometres if we were to draw a line along the Earth. And our speed, 9.5 kilometres. Let's take a look at what's going to happen to the satellite once it's separated.
Following the separation from the launcher, a series of 5 apogee maneuvers will be performed to raise the perigee of the orbit to geostationary height. Once the satellite has reached the geostationary orbit, a series of drift maneuvers will be executed to set the satellite in the IoT position. Finally, it will be set to its nominal Earth pointing mode, and the solar array and antenna reflectors will be deployed. Once the satellite is in the IoT position, an extensive set of tests will be performed at platform, at payload level, to demonstrate that the satellite has survived to the launch. After these tests, the satellite will be positioned in 36 degrees west. After all these operations, the satellite will be ready for its orbital lifetime of 15 years, providing quality and satisfactory services to our customers.
30 minutes and 16 seconds. We are 958 kilometers above Earth and climbing to our transfer orbit. The transfer orbit is our drop-off point, if you like, and of course the satellite will have a long journey of its own to do after that. The Malindi tracking station is tracking all these maneuvers right now, and of course they will be focusing hard, sending the information back here to the Arianespace Center. And the teams who are keeping an eye on those maneuvers here at the Space Center are the real-time visual control teams. You can see them here. They receive the data that comes from the launch vehicle. They analyze that in real time to see how the flight is progressing, and then they send that information through to the range operations manager so that he can make his announcements. And they also analyze the information, the data after the flight, so that they can see how it went and make any improvements or adjustments. We're coming up on separation. Just a reminder that we get our confirmations a little later than the actual scheduled event. That's because the information goes via Moscow. And we have an Arianespace member in the Moscow Mission Control Center, which is called TSUP. And then the information comes back here to the Arianespace Center and the teams we just saw back there in the CVI. We're on altitude now. Our altitude is just above 1,300 kilometers above Earth, so we're at the correct altitude and at the correct speed. We've travelled 12,000 kilometres from the pad across our planet, but we are way above it.
Et confirmation de la séparation de la charge utile Hispasat 36W-1.
We have confirmation there of separation of Hispasat 36W-1, Europe's first ever small GEO satellite, the first one in the small GEO family of small European geostationary satellite buses. And that's what it looks like. Small GEO is effectively pinged into space using a set of springs. The separation mechanism pushes the satellite away. It doesn't look like it's happening fast, but of course it is. Don't forget that it's travelling at between 8 and 9 kilometres per second.